So now we're going to talk about multiplying rational expressions, and we're also going to, in this section, talk about division of rational expression. What's nice about this is that we, again, are using all the same rules that we already know for fractions and using those same factoring skills. I want to just take, again, a step back and look at the actual multiplication of fractions. So when we are multiplying fractions, remember we just multiply the numerators and multiply the denominators, remembering that we need to simplify if we can. There's nothing I can simplify, so in this case I just multiply together. Now if you are looking at something like 2/5 times 10/11, I'm going to go ahead and use a technique that I do in Dev Math 1, and that is I'm going to take the prime factors of anything that is not already in prime form. So 10, the prime factorization of that is 2 times 5, and then here in our denominator we've got 5, which is prime, and 11, which is prime. And what this does is it allows us to see what's the same in the top and the bottom, so we can very easily simplify. This goes to the same idea where it has to all be factors, and once it's in factored form, I can again simplify anything out that is the same in the numerator and in the denominator. And once I'm done with that, I just multiply back whatever's left with a regular fraction, and I'm done. Now when we do this with rational expressions, we do it very similarly. We just don't have to multiply it back together when we're done. So same steps. We literally use everything the same that we did for fractions. We have to factor completely the numerator and the denominator the same way we did when we were simplifying. And then we do the same thing that we just did when I did the prime factorization. So we put the numerators together, and then we put the denominators together, and then we simply, again, look for anything that's the same top and bottom to simplify it. Now I'm going to take a step back and just do a couple basic ones. And these are things that we might have done in, again, Dev Math 1. They're fairly straightforward, but I want to go ahead and use that same technique where I'm putting everything into factored form. So here I've got 15, so that's 3 times 5, and then of course a squared is simply a times a, and then times the 7. So that's all the numerators in their most basic form. And then 14 here is 2 times 7. And then this is 5 times a. And now we go through and we look for anything that's the same in the numerator and the denominator. So here's a 7, here's the 5, here's an a, and whatever's left over and here we just have a 2 in the denominator, is in its most simplified form. So we get to multiply and simplify basically at the same time when we use this method. Let's go ahead and do this next one. So 12 is 3 times 4, or 3 times 2 times 2, and then 4 x's. You can see why this isn't the most fun method, but it will hopefully get the point across. And now we've got -8. So I'm just going to put a -1 here. And then 8 is 2 times 2 times 2, and 5 x's. So see how kind of complex this gets when we write it out, and this is why we want to take shortcuts that we learn. Now we've got 18, which is 3 times 3 times 2, and 3 x's. And then we've got 2 times 2 and 2 x's. And now we are looking for anything the same in the numerator and the denominator. So here we have a 3 and a 2, and here we've got x, 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 Here we've got some 2's and x's. And I really do tend to do this because it's really easy to miss things if you don't. So what I usually do at this point is I go back and I circle anything that I haven't simplified out. So got my x, got my -1, and let's see, we've got some more x's here. So now I multiply everything back in the numerator. So I've got a -2. So we've got the 2, here's the negative, so I've got a -2. And then I've got 3 x's, so I've got x cubed. And in the denominator, I missed an x. I missed a 2, excuse me. That's why I like to circle them. So what I have is -4x to the third. And did I miss anything in the denominator? No. So I just have the 3 in the denominator. And we have taken a long road to get that simplified. But I want you to see how it works. Now, the idea is we put everything into factored form and we simplify it out. Again, everything into factored form. So it's all things that are multiplying and dividing. So here's a couple more problems. Again, I'm going to put this into factored form. So I've got 2. And c plus d is in factored form, so I don't have to do anything to that. 18 is 2 times 3 times 3. And then the denominator, we have a 3 times 6. And then we have 2 c plus d's. And now we look for anything that's the same in the numerator and in the denominator. So we see that we've got, let's factor that out. Let's make that really easy to see. So let's do 2 times 3 here. And then that makes it nice and easy to see just for a few times that we're doing this. There's our 2's. And now we've got c plus d. Here's a 3. Here's another 3. And then what's left over is 2 in the numerator and c plus d in the denominator. And that is, again, in its most simplified form. So let's take a look at the next one. And again, we need to put everything into factored form. So here we are going to factor everything. So here we have in the numerator in our first factor, right here, we've got this little guy right there. So we're going to factor that. We see we've got a GCF, and that gives us x minus 3. And then we factor this next. Again, a GCF of 4 and x plus 3. And then we look at our denominators. So we've got that, which is 3x plus 3. And then we look at this one, which has a 6, and again, x minus 3. And I didn't do prime factorizations of our numbers. We're just going to do the shortcut that most of us do from now on with these. So I see I've got an x minus 3. I see I've got an x plus 3. And now I see that I've got a 2 here and a 2 there. And now I'm going to go back and multiply anything that hasn't been simplified out. And we've simplified that as far as it can go. Let's look at the next one. And the next one is interesting just because it's dealing with some old concepts that we need to bring in here. Here we see that everything has the x first except for this one. So we're going to rewrite this. So it has negative x plus 5. And this one we're going to switch the order of this to, just because we like that better. And now we've got this. And then what we need to see is, we can see that these are the same. But this other one has an issue. But I'm going to go ahead and factor a -1 out of that. Remember, that's one of the techniques that we used when we were simplifying. So -1, that gives me an x minus 5. We'll bring our other numerator factor up there. And then we have x plus 5 again, and x minus 5. And we look for anything that's the same in the numerator and the denominator. So here we've got an x plus 5 and an x plus 5. Here's an x minus 5 and an x minus 5. What's left over is just simply a -1. So we get different variations on the theme. The last couple that we did were interesting looking polynomials that ended up simplifying into just a regular fraction. And of course that doesn't always happen. So I'm going to go ahead and look at this next one, and we see that we've got 7q minus 1, 6q plus 1 in the numerator. And in the denominator, notice that our exponents are on the parentheses. So we've got 2q plus 1s. So I'm going to write them out separately so we don't forget that. And then the other one is a q minus 1. And again, anything the same, numerator and denominator. Here's a q minus 1. Here's a q plus 1. And then is there anything with the numbers that we can simplify? And we see that we've got a 6 here and a 3 here. And of course 3 goes into both of those. And now we're going to go back and circle anything that we haven't simplified out so we don't forget. So we multiply them back together. 14 in the numerator, 3, and then we can't, well, we can, but we don't need to multiply our variable factors back, so we just bring them over. Now let's simplify, or excuse me, factor the next one. And there's a little bit of a process here, and I'm going to factor these pretty quickly because that's not where we want to spend the time. So I'm factoring this guy right now. And when you're doing this, you should definitely go back and check to make sure that you haven't made any errors when you were factoring before you try to do the rest of it. So now we're going to go ahead and factor this one. And remember, you're going to take as much time as you need to do this. So we factored both of the numerator polynomials, and now we're going to get this one. And the next one, which is a trinomial with a leading coefficient of 1 here. And now we go back, once you get everything factored, and again, I don't expect you to be able to do them as quickly as I'm going to do them. So you take your time with that. You may even want to pause to make sure that before I show the factoring, so you can make sure that you can get it factored on your own. And then we look for anything the same top and bottom. So go x minus 1, 2x minus 1, and the only thing that's left is this and this. So we have 4x minus 1 in the numerator and 3x minus 2 in the denominator. If you need to put those parentheses around to remind yourself that you can't simplify any further, then do that. Okay, again, I suggest the same thing, so pause so you can have a few minutes. I'm going to go ahead and get this thing factored. nothing to factor in that second polynomial, rational expression rather. And again, now I'm going to look at this. And just bring that over. And as soon as you've got it in completely factored form, you're looking for anything that's the same top or bottom. Remember that you can't do any simplifying until everything is in completely factored form. So x minus 2, x minus 5, and whatever's left over, we have multiplied it and it is now in completely factored form, simplified form. And remember, if you need to put that parentheses around there to remind yourself that you can't do anything else with that, that's fine. Now let's look at the next one. Go ahead and factor the difference of perfect squares. The next numerator has a GCF. We factor that out. And then we look at the denominator. Well, the denominator is x times x. I'll go ahead and write that out. And then this trinomial with a leading coefficient of 1. And we look for anything that's the same in the numerator and in the denominator. And we see that we've got x minus 3, we've got an x, and there's nothing else, so we just bring everything over. And notice that I'm not multiplying it back, that's just extra work. And 9 times out of 10 when we have to do work, further work with this, because remember, this is just taking us to a place where we can do more work with it, we usually have to have it in factored form, so it's good just to leave it that way. And let's go ahead and do one more example. So that's x to the 4th minus 16. So that's x squared plus 4, x squared minus 4. Well, that can be factored further. So that's x plus 2, x minus 2. So remember that you've got to take the time to make sure everything is in completely factored form. So I'm going to go ahead and write that down here. And all I've done is factor this first one. So every time you do these, you're really getting practice factoring, or with our factoring techniques. And you get to do it 4 times. X squared plus 1, we remember that it is a sum of perfect squares, and that's not factorable, so we just bring it here. And then we see this one, x to the 4th minus 1. So that, of course, is x squared plus 1, x squared minus 1. This one can be factored further. And that, of course, is x plus 1, x minus 1. And now we look at this. Again, the sum of squares, can't do anything with that. And now we look for anything the same top and bottom. So we've got x squared plus 4. We've got x squared plus 1. And then there's nothing else the same, so we just bring them with x plus 2, x minus 2, and the denominator is x plus 1, x minus 1, and we're good to go.